All right. Okay. We'll give another couple minutes for people to wander in. Can you let me know in the chat if you can hear everything okay? If you can kind of read my screen here and see what's going on. And we'll see. All right. Okay. Just wait a couple minutes. Thanks for joining me, by the way. Perfect. Thanks, Julian. There's about a 10 or 15 second lag between when I'm going to read what you say and when you're going to hear what I'm saying. So, but feel free to, anything anybody specifically wants to learn about today. I was planning on going through basically some simple lenses and traversals, how to build them from scratch. I know that's something that people don't really cover a lot, and then maybe if we get into it, I might actually build like a kind of a Markdown table parser and editor with traversals or something. I have never done that before, so it'll be kind of an experiment for all of us, I guess, but should be kind of fun. But yeah, I don't know. I've done a bunch of lensy traversal style text manipulation stuff with the lens regex library I released. It's actually a really powerful abstraction to be able to do that, and I think basically the lensy tools in Haskell for working with text, I don't know, there just aren't a lot of them yet, and I'd like to see more, because basically it's a really nice abstraction. It's really nice mapping. A friend of mine, Sandy McGuire, sent me a message the other day just talking about he was getting source spans from GHC, and he wanted to be able to like actually just access those source spans within a document. And I'm like, oh yeah, that's like a super lensy thing to do, access row 15 column 3 until row 17 column whatever, and there was just like no way to do it, so we had to build it from scratch, and that was kind of a pain. So we might end up building something like that here today too, but it's pretty finicky to work with. Give it another minute, and then we'll get started from scratch. For those who are just hopping in, I'm going to be doing some lensy and traversal text manipulation. If there's anything specifically you'd really love to see or implement, or if you're super interested in ISOs or prisms or traversals or whatever, feel free to drop ideas in the chat, and maybe we can look at that. I'm not going to make any promises, but I'd love to do something like that. So how's everybody's day going? Hopefully well. I went out for a walk a little earlier. It's really beautiful out. It's the middle of the afternoon here in sunny Saskatchewan. Say that 10 times fast. All right, guess we'll get started. So we're gonna build this library from scratch. So hey Etienne, good to see you. Hope everything's going well in Germany. Let's start a new project. So hey Tom, thanks for making it. Love that emoji. So I'm gonna make a new stack project. I use this like stack new command that I wrote. It's just an alias. It's a little shell function that always uses the same resolver. So this is really handy. Stack by default will always use the latest resolver, which is really annoying because then you have to rebuild lens from scratch every new project you make. So I just have a little file where I hard code it to an LTS that I only update every couple months. So let's make I think I made one of these earlier. I'm just going to kill it. Yeah. All right, so let's make a new project. I'm just gonna call it Texty Lens. There we go. All right. Gabriel, good to see you too. Lots of people from the Slack showing up. That's awesome. If you haven't joined the functional programming Slack, I recommend checking it out. Okay, so we can see my little command has created a new project, and I have it set up to make a Git repo too, because that's just handy. So we're gonna go in here. I'm gonna make a new tmux session. I like to use tmux. So if you've never made a new project before, I use Stack. That's what I like to use. It just makes things pretty easy to work with, and it uses hpacks, so we get these nice little package.yamls. So I'm going to jump in here. This project, we're going to be working with text, and of course we're going to be using lenses. I'm going to use Comet's standard lens library. I don't know what else we'll need. We can add it as we need it. I'm going to add byte string just in case. I don't know. Who knows? Good enough for me. Okay, so we'll run a stack build, get my project set up. Hey Christian, thanks for dropping in. Awesome. Yeah, I was saying earlier, if anyone has anything they want to look at, you can let me know. We'll see if we get there. So let's open up this lib. So I'll show you some ideas I kind of had. I did a lot of work on. Oh, what's going on here? Yeah, okay. Oh, it failed. Stack has not been tested with blah blah blah. Oh, that's not good. Alright, let's see what's going on here. Okay, well, that's bizarre. I don't get that often, but not sure what's going on there. So I'm just going to switch the LTS to something that I'm like pretty sure works. I think I used 1422 earlier. See if I can get my editor tooling working, because that's always handy. Hey Barry, thanks for dropping in. You're only getting 480p. Let's bump it up a little bit. If I go too much bigger, we're not going to have a whole lot of screen room, but hopefully that's a little better. Wonder if I can crank up the resolution here. It could just be my network connection though. I think I set it as high as I could. But hopefully that's a little better. Perfect. Yeah, thanks for letting me know. Okay, so hopefully I switched LTS here. Hopefully this one works. Alright, yeah, that's a little better. I use intro, so it just kind of lets me experiment as I'm programming. So we start off with a little empty lib here. I'm just going to clean it up. We're just going to say module lib where that's going to complain about my main. So I'm just going to stub all this stuff out right here. We don't need the lib. Great. Okay. So perfect. So what I was thinking, I'll show you something I was working on. Some of you might know I used to, I kind of prototyped, my first Haskell project ever actually was a text editor in Haskell called Rasa, R-A-S-A. And so I learned pretty much everything I know about Haskell working on a text editor. And at one point, I wanted to use lenses for all of the text manipulations. So I kind of built this little project that exposes some kind of shitty lenses on how to manipulate text. So I have a lot of helper functions. So before, it just like is a lens that focuses all of the text before a given byte, after a given byte, set amount of words. I have a bunch of these that are like inclusive, exclusive, ranges, matching certain text. I can split on stuff. So I think we're going to do some similar stuff. I've learned a ton since I originally wrote this, so our new one's going to be better. Probably not better documented, but at least a little bit better. So let's start with our first lensy traversal thingamabob. What's something silly we can do? Let's see if we can get, like, just take the first n bytes of a text object. So there are lots of ways to kind of do this using existing lensy stuff, but the reason that I don't love it is because you basically have to treat your text as a list of characters, which, you know, if you're switching back and forth all the time, that's going to slow things down. It's going to be a little tough to work with, too. So, for instance, one thing that we can do, Out here, let's set some extensions. So I'm gonna need overloaded strings because we're working with text a lot. Probably gonna need rank-n types. Actually, you know what? I'll let that come up when it comes up, just so that people can see when you need rank-n types. So we're gonna write our first lens. Let's just say taking n. So this is gonna be, it's gonna take an integer, which takes the first n characters of our text object. And what we're gonna do is, so this could either be a lens or a traversal. It kind of depends on whether we want to treat it as failure if you don't have enough in your sequence. I'm gonna have this behave kind of like all of the other taking and dropping and whatever, where it doesn't fail if it's missing, it just takes as much as it can. So, you know, if you ask for 10 and there's only 3 characters, it'll just focus the 3 characters. And we're gonna make this a traversal. Actually, this could be a lens, but it doesn't really make sense to set the first n bytes if they don't exist. We'll start with this. I'm gonna import text here. Cool. Okay, cool. And this is something called a simple traversal. So I'm gonna add this little tick here, and that just means it doesn't do any fancy type changing as you go. Oh, I do need to import lens, don't I? Import control.lens. Great. Okay. So now we can take in, and okay, so here's a fun part. Writing traversals by hand, nobody ever tells you how to do, well, I mean, I do in my book, teach you how to do this, but there's really, like, nobody really shows you how to actually do this. There's no, and unlike lens and prism, there's no built-in combinators to help you write a traversal. So this is a really tough sticking point for a lot of people. What am I using for autocomplete company mode? No, actually I'm in Vim, not Emacs at the moment. So I use something called coc.vim. I actually technically use NeoVim. And coc it's kind of a wrapper around language server protocol. So I'm actually using GHC IDE. That's Neil's new kind of IDE project, and it works pretty well. I actually do get autocomplete on modules and things too, so you know, if I say data dot whatever, you can see this has the ls on there. It means it's coming from the language server. So that works pretty well. I definitely recommend it. They also, you know, give me the squiggles, and NeoVim has these cool pop-up windows and stuff, so that's a whole conversation on its own. So what was I saying? Okay, so if we do want to make a traversal, the key thing to remember is that the type of a traversal is actually just the exact same as the type of the traverse function. Yeah, Emacs and Vim look pretty similar, don't they? So type traversal STAB equals, let's see if I can do this from memory, A to F of B, S to F of T. Okay, so this is roughly what we're dealing with. And this is actually existentially quantified on F. So what is a traversal? Well, we can actually line this up with our normal traverse function. So if I go over here and I say, oh, what's the type of traverse? You can see it prints this out. I'll carry this over. Okay, so traverse here has this type. So we're going to ignore this for now. But if I just pull this part of the type and put it underneath here, you can see the similarities right away. So basically, the only difference between these two is that one of them has a single type parameter for the container, so in this case t, and the other has this kind of wrapper type. So if we were traversing a list or whatever, this would be a list of A's and a list of B's, you know, something like that. And this effect can be anything, so let's just specialize it to IO for now. So if you were doing like traversing print over a list of items, this is kind of what it would look like. Okay, so what's the difference between these? Well, you can see in the Lensy version, we don't need this to be a higher order functor, for this to actually be a functor or a traversable. Gabe, is a Van Laerhoven lens just traversal specialized to a functor? Am I remembering that right. Okay, so Van Laerhoven lenses are anything of basically this type here. We'll see if we actually end up writing anything today or whether we just talk about lenses, but there's not enough out there about lenses, so let's talk about them. So this is, yeah, I'm implicitly talking about Van Laerhoven lenses rather than like Functor or other encodings. This is what a Van Laerhoven lens looks like, or however you like to pronounce that. And the way that we can tell the difference between a lens and a traversal and a, well, prisms are a little different, but lenses and traversals for sure, is that we can specialize this F in our existential quantification with different requirements on it. So if you see here on our traverse function, traversable we don't really care about, but it requires applicative on the F. It doesn't care which F you use, it just needs to be applicative. And so on traversal, which of course gets its name from traverse, we have also this applicative F effect. All right, so if we actually, let's see if I can get it to print out. I'm not sure I'll be able to, but if we're lucky, let's see if I can do what kind of, I don't know, a traversal, yeah, non-scope. Okay, let's try what, int and string, just to have two different types. No, it does not like that. Okay, so let's jump into, I'll pull up a browser here. We'll just expand the type synonym. Oh, I wonder if I can just do info on it. Info traversal. Not an, oh, I need to import. Why is this not imported? I need to load my module. Oh, that's why it's not loading, because I have all this junk in here. Okay. Everything's broken. Okay, there we go. So I've loaded the module. So now I should be able to do, I should really set the prompt here to, I don't know. Can I do that? Set prompt. Some flags. I don't know how to do that. Okay. Let's try info on traversal. There we go. Okay, perfect. Oh, that's not very helpful. Let's do the fully expanded version. So if I pull this up, we can see the actual definition of a traversal has this applicative constraint on the F. And, you know, it's polykinded and all that good stuff. And this is where we get all of the magic. So this is what allows us to, the fact that this is fully generalizable over the F, and because it's quantified, a traversal cannot specify which type of F it wants to use. That's up to the caller. And the caller, by specializing this F, can basically run edits or traversals, or you can view, or you can set, or you can update. Basically, the caller gets to choose that. We're not going to implement it completely from scratch. Like, we're not going to implement our Lenzy combinators, although that would actually be a really great stream. So maybe I'll do that another day. Unless, actually, if people would prefer that, we can do that today. Just let me know in the chat. That's always fun, kind of implementing. We could implement a Functor optics library or something. Thank you. Okay, set prompt. I just had an equal sign in there. Okay, there we go. Perfect. Thanks, Christian. Okay. So anyway, hopefully that kind of clears it up, but we'll keep going here. So we'll keep this function signature in mind, and we'll actually write it. So maybe that'll be more clear if we actually write the function. So anytime you're actually writing a traversal, when you're starting out, once you get used to it, it's not a big deal. But when you're starting out, I would recommend expanding all of the type synonyms here. So I'm basically going to just replace it with this definition here. Now, your STAB, if you're not used to basically what, like, so we could do this higher order or whatever, rank n, but there's really no need to. We can just put it here because we'll replace it again with the synonym when we're done. So we can see, now that we've expanded it, so S, T, A, and B, S and T are going to be kind of the source type, like the larger structure, and A and B are going to be the focus before modification and the focus after modification. In our case, all 4 of those are just text. So we're just going to do that. It's going to be much easier to read. Okay. So, but now I just kind of need to know what's going on here. So we take an n, which is going to be the number of characters we want to focus in our input text. And then what's this? So this is kind of I like to call it like a handler that is being passed to us from who knows where. We're not allowed to know where. The calling action, so whether we're viewing this text or whether we're setting this text or whatever, is going to be the one that actually passes this in. And so we not only don't know what this is going to do, we're not allowed to know what this is going to do because it could do anything. It could use any implicative it wants. So we just have to use it. And what we do is we use it to focus the text that we want. We pass it in the text that we want to either view or modify or delete. And then we can basically process it, and then we need to return what we want our output structure to be. And then I'll show you how we basically rebuild the output text object. So first off, let's just get the text that we want to actually edit. So in this case, if we're going to say we want to take and focus the first n characters of a text object, let's see what we have in our text API for basically doing that. I'm pretty sure text just has like a take on it. Oops, why can I not open this? There we go. All right, so let's just go to hopefully you guys can see this. Yeah, I think you can. Oops, let's go to the text package. Great. And this is just our standard Haskell text package. So I think we just have a take. Yep. And this is perfect, right? It takes a certain amount of text. But the problem is that because this is a traversal, we can't just take the text, edit it, and then spit it back out. We need to, basically, we're focusing this text in a larger structure, which means after we edit it, we need to re-embed the result in the original structure. That's how traversals work. They edit part of it and leave everything else alone and rebuild the structure around it. So what we need to do is we need to know not only the text that we're focused on, but the remaining text that's left over. So I think they have something called split. What is it? Split at? Yeah, split at. So this is great. So this will, given a text, give us the first n characters and the remainder, which we're going to need when we basically re-embed. So let's say that let's just do a where clause here. So the prefix, the part that we're interested in, is going to, do this. Oh, okay. Don't mind, this is, I have kind of these column highlights turned on, so they just kind of slot in like that. That's not a real character, don't worry about that. It's not going to be a syntax error. That's confusing, I should turn that off for live streams. So where the prefix and we'll also get the suffix are going to be, we're going to use text and we're going to split at our n on. Now, where do we get our input text? Well, so this parameter here, which was originally the s of our traversal, is going to be the input text, and then we need to somehow return our output text. This is this is the full text, not just the focused bit. So I'm going to bind it here as text. So you can see it passes us the handler and the input text, and then we have to output this. So let's split that. Now we've got our prefix and our suffix, and hopefully that'll do what we want. Let's get some sample text here that we can play with. So I don't know about you, I always go with Alice in Wonderland because it's Alice in Wonderland text. Because it's freely available and it's public domain, so it's really easy to work with. So let's just grab a paragraph from here. Cool. And we're just going to call this Alice, and we'll paste that paragraph in there. Oh, look, it's got smart quotes and everything. I'm just going to take those out because those are probably going to confuse me later. Great. Okay. Cool. And Alice is a text object. Great. All right, so let's jump into our live editor thing here. And I am going to need to make this compile again. There we go. So we should have Alice here, yep. And let's just make sure that our split at is working properly. So let's say we want to focus Alice. So that's 1, 2, 3, 4, 5 characters. So I don't know if we want to split at 5 or split at 6 here. Yeah, okay, so if we take 5 characters, it'll get the first 5 and then return the remainder. So that's exactly what we want. All right, so we've split off the first 5 and the last remainder in this specific example. Now what we need to do is we have this handler, but we want to run the handler on the prefix, right? Because we want to focus the first bit of it. Now what is this handler going to return? Well, it's going to return something, some text, after maybe some modification or maybe not. We really don't know what's going to happen to that text. But it is going to return us the transformed prefix inside some applicative. Now it's inside this applicative, which means we can't just, reappend it to the suffix and go on our merry way. This is going to be a type error. You can see here, can't match f of text with actual type text. So we can't do that, but we do know how to work with applicatives, right? So we can work within that applicative by just, in this case, we can just fmap. So this is also why this could technically be a lens, because we don't actually need the full applicative, but we'll do it as a traversal just because semantically it kind of makes more sense. So I'm going to lift A2, which I'm probably going to need to import. Let's import control applicative. And we'll group this up. And I'm just going to do pure here because why not? It kind of makes sense. Okay, so what we're doing here, feel free to throw any questions in the chat if you want me to slow down or dive into something a little deeper. So what we're doing here is we're lifting the semigroup append into the applicative that's going to be returned by running this handler. And this applicative, so I guess I'll give you some examples of applicatives this could be. So for instance, if you're, if you're doing like an update or a modification, this applicative is going to be, at least in the lens library, literally identity. We're not allowed to know that because it could be something else in different circumstances, but it's literally just going to be identity. So when we lift A2, we're just going to take whatever the transform text is and literally just append it here. But we could be traversing with, for instance, like we could just traverse with the list applicative, in which case we would get the, and I'll demo all of these. Actually, now that this is working, let's demo these. So, all right, let's reload. Perfect. So we should have, if we did this right, taking n should be, what's the type there? Oh, okay, and I'll show this off too. So now that we're done, we should be able to switch the type signature back to a traversal. It's a simple traversal, that's why I have the little tick there. Text to text. So this says we're going to focus, that's the second parameter, text, inside larger text. So not the illegal polymorphic type, rank n types. Yeah, so as I said earlier, we're going to need rank n types. Basically, anytime you work with lenses, just turn on rank n types. It's not a big deal. Great, and that's just because there is a for all hidden inside the traversal type synonym. Okay, perfect. So now if I do type of taking n, okay, so I think I reloaded, yeah? Yeah, I did. Okay, so GHCI is unhelpfully expanding that again. But we can see that it's happy with the type signature we gave it with the traversal. So that means we at least wrote it right. So now let's say we want to taking n. Let's take the first 5 of Alice. So this is a traversal, which means we can use, for instance, I'll do Alice and then can do kind of like lensy access here. So taking n5, and there we go. We got the first 5 characters. But because it's traversal, we can also, let's set the first 5 characters. Whoops, Alice, and we'll set the first 5 characters I think it couldn't be a lens because it would fail push-pull if I did something naughty like taking n0. So it kind of depends. So it depends how you want to handle that. Most of the text lenses and traversals are actually unlawful anyways, just due to kind of the nature of the situation. Like you're editing the text, if you're doing pattern matching and stuff like that, you're going to be invalidating the invariance. But I've long been a believer that like the lens laws are some of the more flexible laws, like not in the sense that they don't have rules, but more in the sense that it doesn't matter as much if you break them. Maybe that's a hot take, I don't know. I break them all the time. For instance, like the regex library, most of those are unlawful lenses and traversals, but it's really not a big deal because the laws for those are like kind of more structural and mathematic laws that like don't, I want to say they don't apply in like practical programming, like in the real world. So basically the traversal law that gets in everyone's way, or at least gets in my way, is the law that each time that you use the traversal, it must always focus the same like number of elements and the same elements in a structure. So one clear example of something that breaks this is the filtered traversal. So here, I can actually demo this. So let's say I have a list of numbers here. So 1, 2, 3, 4, 5. Okay, so great, list of numbers. And I want to, let's just say I want to traverse it. And I want to, so that what that'll do is it'll focus each number in the list using the traversable instance. And I'm going to throw in filtered here. Actually, so if I just traverse it, let's see everything that it traverses as a list. So here I'm just basically collecting all of the elements that I traverse over into a list. Okay, so obviously it's everything. That's great. But if I add filtered here, I can filter for even numbers, right? And so if I run that, I only get 2 and 4, okay? So filtered is an illegal, well, unlawful traversal because if I edit something through this traversal, so I'm going to switch this to and, which means basically take whatever's to the left, pipe it through this next action. And an action, you typically don't add these parens here, but I'll add them just for clarity's sake. I can, for instance, set everything to the number 3. Okay, so I'm going to set every even number in this list to 3. Okay, great, cool. So now we have 1, 3, 3, 3, 3, 5. But the problem is that after I've edited this, if I want to, for instance, view, let's capture this result here. So I'm just going to say let x equals that. So now we've got x is this weird edited one. Now if I view through here, and I view through the exact same lens, I should probably talk about that in the book. I mention a couple times that they're not super important, but I do have chapters on lenses in there. The laws. Obviously I have chapters on lenses in my lens book. So anyway, so here we can see now we've run the exact same filter or traversal, but now we get 0 elements, and that's breaking the traversal laws, even though, I mean, that's exactly what we expect, right? Like, we're focusing all of the even numbers. If we make them not even anymore, we wouldn't expect them to be focused. So this is why I'm like, well, for practical purposes, yes, this behaved exactly how I expect, even though it technically breaks the traversal laws. So I don't really care in this case, and I'm not going to really care with the thing we're working on here. So where were we? So we can view through it. Let's see if we set through it. So let's, oh, whoops, what am I doing? And this little dot tilde here is the set operator. It just says, hey, whatever you focused, make it now this thing. So I can say this thing here. No, I need overloaded set x overloaded strings. Okay, cool. Try again. Perfect. So now we can see we've changed the first 5 characters from Alice into thing. Congratulations, awesome job. Now, what if we do a different number of characters? Well, this is where things kind of get fun. So, um, I'll show you the kind of existing way that you can do this, and how it differs. So if I want to, I can actually delete the first 5 characters just by setting them to the empty text object, like an empty string, and you can see I've just deleted it. It's gone. Now this is unlawful, but really useful, right? So if we're going to be focusing and manipulating text, we want to be able to like change the length of it and delete it and whatever. But the problem is that it does make it not idempotent. So like if I run this again, like literally the exact same thing, if I take the next 5 and then delete it again, I'm going to delete another 5 characters. You can see now I've changed from like this at the beginning. Now I've actually deleted more. So this is unlawful, but it's really useful. Because obviously if you want to delete another 5 characters, you should be able to do that. And if we insisted on making all of these traversals like lawful or whatever, this wouldn't really work out. So yeah, so we're not going to care about being too lawful. I'm not going to throw the laws completely out the window, but I'll mention when we're breaking them and why we're doing that. So this is great. So we can set it to nothing. I'll show you actually what happens if we start traversing using different functors. Yeah, no problem, Tom. I don't think there's enough people talking about lenses really, and that's probably because they're a little tricky to understand. I try to maybe address that with my book. Anyone listening who hasn't heard, I have a book on optics called Optics by Example. You can find that on LeanPub. Check it out. There's a free sample there if you want to check it out. But I really do love talking about lenses, and I think traversals and lenses are like one of the coolest new things in programming to hit in a very, very long time. And we're starting to realize there are applications in a lot of areas that people just hadn't, like they didn't have a formalism for before. So you may have heard of things like, for instance, closures transducers. So they basically were like, oh, hey, map folds reduce are really, really handy, but you can't always compose them in the ways that we want to. For instance, you can't really compose a map and a filter in most cases, right? You can map and then filter, but then if you wanted the filter to focus rather than actually just dropping elements on the floor, you just can't do it, right? It just erases them, they're gone, and that gets really annoying. So, for instance, if you have a list of users and you want to only edit the users who live in Canada, then you can't use filter to do that because it'll just erase the users who aren't in Canada. So Clojure kind of uses these transducer things for composing these pipelines, but they ran into a couple problems with it, and it got confusing, and it was a new concept and whatever. Well, it turns out optics actually completely encompass transducers, and they do it in a really principled way. They also basically just replace any bidirectional data transformations that you can think of. As it turns out, the beautiful folds libraries, because folds are technically profunctors, well, not technically, they just are profunctors, because they take input and they have output. You can use them directly with a profunctor optics library, which is really cool. Functions are profunctors, so they work really well with the profunctor optics library. There's a lot of these abstractions that just kind of tie together really nicely. And now with modern work that's happening on it, we're actually learning how we can use optics to do convolution, and there's papers on using optics for database projections. So if you think of a SQL, a table view or something, you can project records from a SQL table into some view of those. Say we only want field A and field B, and we want to ignore the rest. But the cool thing about using an optics take on it is you can now edit that view. So if we edit field A and edit field B or whatever, we can map that back onto the original table. Now that sounds really, obvious and trivial when it's literally just editing fields. But where traversals come in is you can do much, much more complex edits, and we have a language for talking about how to embed the result back in the original context, which is what I do with the lens regex library, right? We can run these really complex queries like, basically parsing. Like you can find like JSON objects and then parse in text, parse the JSON, and then you can turn it into a Haskell object, edit it, use lenses and traversals to edit that object, and then it will automatically, you don't have to specify how, it will do the round trip for you, and it'll reserialize it back into text and embed it back where it found the original JSON object with the regular expression. I also do this with the lens CSV library, where basically you can parse every row into an object, and you can use lenses to you can focus things. So you can focus column A and column B over the entire spreadsheet, turn those into an object, edit them, and then project them back into the CSV, and then dump it into text, and it all just works. And actually, I believe, I haven't done a ton of testing on my CSV lens library, but I believe it can actually stream all of these updates, as long as you're not doing something that isn't streamable, obviously, but it's pretty cool. So anyway, we can delete stuff. Hopefully people like certain amounts of rants. So what was I going to say? Okay, let's take some smaller text here. So let's take like a little Mary had a little lamb. Okay. And let's do some different traversals. So I'm going to use the generic traverse of operation here. So I can also actually, you know what, I'll write the long form version first. This is a weird one to get used to. Traverse of. So most of these of combinators, they just take an optic that you want to run them on. So I'm going to say, let's take the traversal of the first 5 characters, and then what do I want to do with that is basically what it's going to ask. So this needs to be a function from text to f of text. Now that f can be anything I want, and that's where we're going to have a little bit of fun. So let's take, and I'll take the first 4 just so we get Mary here. So I'm going to make a little lambda here, and we're going to say we get some text. I'm going to choose list to be my applicative here. So the list applicative does basically like Cartesian product. So it's going to, or I like to call it like the non-determinism. Technically it's deterministic, but it's kind of like find me all of the possible outcomes using these as your input. So I'm going to say let's keep the original text and let's see what happens if we uppercase it. I think this is how you do that. Okay. So we're going to pass in Mary had a little lamb. We're going to take the first 4 characters. Then we're going to dump it into a list and return the original text and the uppercase text. Okay? And then we're going to run the traversal, which if you know how traverse works, it's basically going to take that list from the inner part, like our focus, and it's going to pull it to the outside. Let's see. Yeah, little lambda. Okay. Thank you. I'm better at puns than I thought. I didn't even notice that. Brilliant. Cool. Okay. So when I traversed, what happened? Well, it found the focus, parameterized it by, these 2 behaviors, and then said, okay, what happens, what are all of the possible structures that exist if I had edited the focus in this way and edited the focus in this way? And you can see, actually, we get Mary had a little lamb and all caps Mary had a little lamb. We can add another one in here. Let's run this again, and let's add t.reverse of text. So we expect another possibility here where Mary is reversed. Very cool. And we can do this over any traversal, right? Now I can also pick a different effect, right? So if instead of, embedding it in this map thing, I'm just going to say print. What's the problem? Oh, it has to return the original text. So I'm going to, right? So this has to be a transformation from text to f of text. So I'm going to print the text, and then I'm going to just return it. Cool. So you can see we've printed our focus and returned some result. So we can make these different if we want. So rather than returning the text, we can return, blanks or something, and it'll blank it out. And we've printed it and also removed it from the original string, which is kind of cool. Cool. All right. So seems like this one's working. Any questions on basically how to write a simple traversal before we move on to something else? Oh, my allergies are getting bad. Oh, my nose is getting itchy. So this is, yeah, simple traversal. We can set it. We can, fun little hack with traversals is that normally with traversals you use this one, so a little hat ... which is infix of to list of. But so we can say take a list of the first n things, and it's just gonna embed that in a list, and that handles failure for us. We can also do the question mark, which is preview, and it'll say, oh, did I find anything? But because text is a monoid, we can use this one called view, and if it's missing, it will just return the empty, which in this case is empty text. So we can save the wrapper here if we want, which is pretty cool. Have I compared Haskell IDE engine and GHC IDE? I tried out Haskell IDE engine a long time ago when it was in a bit rougher shape than from what I hear it is now. From what I've heard from friends, it's working pretty well these days, but GHCID just kind of works for me, and it's a little bit lighter weight. It doesn't melt my computer. So, and it seems like there's a lot of work being done on it, so I just use that. It's pretty easy for me to set up, so I'm happy with GHCID. I was for a long time using literally just intro to do all of my development, so I'm pretty used to a lightweight setup, so I'm not too concerned about having all of the IDE tools in the world, although managed imports would be really nice. I'm just ecstatic to have errors in my editor now, so that's really nice. Cool. So what can we do next? Well, we have taking in. Let's try dropping in, because that's really easy to do. So I'm going to just say, instead of taking in, we're going to say dropping in, and this is literally going to be the same split at. We're just gonna take the we're gonna now focus the suffix as opposed to the prefix. So I'm gonna move the handler. So now we're running the handler on the suffix, and I'm just going to return the prefix. I know I can just use fmap here, but for the purposes of demonstrating the applicative syntax, I'm gonna leave it like this. Cool. So that was literally all we had to do. So now we should have dropping. So let's try that. So if I take this and I now say dropping N4, we have dropped Mary from the start of this thing, and that's great. I'll show you actually. So we do notice some code duplication here, right? So all of this is exactly the same. Is there a way that we can clean this up? There are many ways that we can clean it up, but the one I'm going to look at, because this is an optics stream, is to use an ISO, so an isomorphism. For those who haven't heard of an ISO before, an isomorphism is, so there's two different things. So an isomorphism is a more general math and category theory term, but then when you're talking about optics, we have specifically an ISO, which is like a type of optic. It's actually probably the simplest optic, even though it's also one of the more powerful ones. And basically an ISO is just a two-way transformation. And according to the laws, it needs to be exactly reversible. Again, if we're being pragmatic, we can kind of fudge that a little bit. There are actually a couple of these that exist that are fudged already. Let's see if I can... Here, let's pull up the lens library. So wording, worded, here we go. Oh yeah, they do just do a traversal. Okay, so this is like one of the ones that could be a pseudo ISO, in the sense that it is kind of reversible to turn something into words and then turn it back. I thought they actually had it as an ISO. Apparently not. A really basic one is, for instance, converting string into text and back, because if you convert a string into text and then back, you should end up with the string you started with, right? So what am I going to use an ISO for? Well, I'm just going to say splitting at is an ISO. So it's kind of interesting in that it's a parameterized ISO. So we take an int, and then we should be able to. So this one is not going to be from text to text. This is going to start at text and then go to text and text. So we can see this is kind of the splitting operation that we have here. It's going to split it into a prefix and a suffix. This is reversible because if we split something into a prefix and suffix, we know how to unsplit it, right? We just rejoin it. So what I'm doing here is I'm taking some of the logic from my previous two things and I'm turning it into its own optic. And the reason I'm doing that is because optics are very composable. They're the building. When we're programming, we're used to abstracting things into functions. When I'm programming with optics, I abstract things into optics because optics compose with other optics. So I'll show you how this kind of works. So let's say we're going to split at n, and we're going to take our input text. So to make an ISO, there is actually a helper for this. It's called ISO. You can kind of see the type at the top here. It takes an S to an A and a B to a T, and it gives you an ISO of STAB. That's not so handy for people who aren't used to it. But typically, we have a to and we have a from. I'm going to use ticks on those just because those are commonly used. They're actually used in Lens, I believe. So the to is going to, we can even just, here, I'll show you. Let's do this. So if I put in my type holes, I can see found error. Okay, so this function has to join the two halves of text together, and this one has to split it into two. So I can go back. So to is going to be my splitting function. And from is going to be the same thing, but backwards. Cool. So to takes some text. Actually, I can probably just say literally to is split at n. I know I could write this more concisely, but it's probably going to be less readable if I do that for people on the stream. So I'm just going to write it all out long form. Like a noob. Okay, there we go. And this one, I mean, I could do uncurry of. If we want to be fun, we could write, what is it, like uncurry of semigroup, but that's not helping anybody. So I'm just going to say A and B, and we're going to do A and B. Done. Okay, way more readable, about the same length. Okay, so what this does, I'll show you in the little REPL here. We can take some text. So let's go back to our Mary example. And we can view through an ISO. And this is going to be, what did I call it? Splitting at. So if I say I want to split it at 4, and I view it through there, great. It splits it into the prefix and the suffix, and then we can do whatever we want from there. And then if we want to go backwards, an ISO can be run in reverse. So here I'm going to have a tuple coming in of, well, technically I guess it would be this. And we can actually view, and we can reverse the ISO by using from, and it'll actually flip that ISO backwards, and now it'll join. So that's cool. I think we can also do this. I think I have them backwards. Let's try, whoops. This isn't super important. Add a little lamb. Let's do this, and let's do splitting. Add 4. There we go. So this is the review symbol, so that'll automatically flip an ISO around. It's not really super interesting. All right. So what does this actually gain us? Splitting this out like this. You wrote a bunch of new code. It's way more complex than it needs to be, although this could have been a one-liner if clarity be damned. let's see, now, instead of basically writing all of this, I can now write taking n. I can delete this. Actually, well, I'll keep our first version around just so we can compare, but I'll make a new one here, which, so now we don't need, so this can also be a point of confusion. I have 2 arguments here, even though it says it just returns a traversal, and that's because a traversal has an additional argument kind of hidden inside there. But now we don't actually care about any of that. We just care about our parameter. We're going to pass that parameter into our ISO. And then since this is an object, and we're creating an object, we can just compose. So I can say, okay, well, I'm going to split it in. And then if I want to focus the prefix, I can just, it's going to be a tuple. I can just use the lens that already exists to focus the prefix. It knows how to reverse itself. All on its own. Splitting at knows how to reverse itself all on its own. So here we go. It just works. And again, this could technically be a lens if we want. Like, this will compile. I think traversal is like a fairer encompassment of what it's actually doing, but that's up for debate. I wouldn't argue too hard about that. So now if we want to do the dropping version, guess what? Done. I changed it to a 2. So you can see here, this basically splitting things into smaller combinators gives us a vocabulary for working in our domain, in this case text. So we really want to build up like these small chunks that we can compose. Alex, is this the string library which uses optics? Well, yeah, I'm working on, we're not really building a full library. I'm just kind of demonstrating optical concepts by hacking on text at the moment. If you had any specific questions, we're happy to dive into it. Purpose is for fun, or is it better in some other way? I would say fun is good. Optics are fun. I enjoy them. But educational, mostly. So hopefully peeps are learning. There's not a whole lot of content on lenses out there, so I like to teach. Yeah, I don't think we're going to actually publish what I end up with today. But I would like to build basically a text lensy optics library at some point. Okay, so let's get to a fun one. So a problem I often have with text is that if you do something like, here, let's jump into here. We have some text like Alice in Wonderland, and we want to split it. So let's say I just run lines on it. So, oops, lines. There we go. Well, of course, lines is a bad example. Let's do words. Okay. So we can see we've got all these words and whatever. But there's a problem with words in that if I have a word with a lot of spaces, many spaces, and maybe like a tab in there or something, and I run that through words, it collapses all of that white space, including tabs, and just like deletes it, which is what words does. But then on the round trip, if we unwords it, well, we've clobbered all of this white space in our original string. So that's not, like, that's good sometimes if you want to normalize. But if we wanted to, for instance, just, focus and let's say reverse every word, so we can do that just by like, okay, after we've words, we can map t.reverse on it and then unwords. So the reason I'm parsing the words is so that I can operate on each individual word, but then I want to like dump it back into its original structure, right? Well, if I do that, sure, I've reversed every word in place, which is really cool, but I lost my tabs and I lost my new lines and all, like it would be totally reasonable to have like a new line in here, but it's just gone. So how can we improve this with optics? This is a kind of like, it seems like a, I don't know, pretty manual thing that you would have to do. Like you're gonna have to map over like you're gonna have to probably do like a fold or an unfold or something, which we might end up doing, but we don't want to do that manually every single time we want to perform an operation like this. We want to abstract it into a combinator so that us and everybody else can just use the combinator, rely on it, pretend that it works, and move on with our day. So let's build one. So what am I going to build? I'm going to build a, let's just call a splitter. So I'm going to make this basically polymorphic over, well, okay, no, let's start with something more concrete first. We can polymorphize it as we get further on here. Oh, where did my stream go? Hopefully it's still streaming. I lost my, there it is. Okay, sorry. Let's write good words, which does this right. Okay, and I'm going to make this a traversal. So what this is going to do is it's going to take in a text. It's going to go through and find all of the words in that text, split them on arbitrary white space, then focus each of those words so that we can edit it or reverse it or uppercase it or print it or whatever. Beautiful thing about traversals is you can do any of that. But the way mine's going to be better than the default is that it is going to be, maybe I'll call this space-preserving words. It is going to try to preserve the original white space when we crunch it back down. So, okay, now for the fun part, how do we actually start? So this doesn't need to be parameterized by anything, but we can expand our little traversal type synonym here, as I like to do. So this is going to be the focus, which will become embedded in an applicative. Then we have our main input and our main output. I set up vernacular for all of these in my book just to kind of coin some terms and get some standard stuff going on. So I call basically the input and the output structures. So this is a larger structure, and then these are the focus. So the input focus and the output focus. Okay, so I'm going to need applicative on this for it to be a proper traversal. And we have our handler. Sometimes I'll call that F. And we have our input text, which I'm just going to call text. Cool. So now for the fun part. So in order to preserve all of our white space round trip, we need to keep it somewhere, right? There's no way, if you just hand us like a list of words, I can't divine which new lines and tabs and whatever you had in the original string. I have to keep that somewhere. But I can't have it show up in the focus text because it's just not in our type. And we don't want to have the user have to deal with managing a bunch of extra stuff. So I'll show you a trick that I used in my Lensy regex library. We'll see if we can do it a little bit more concisely here. This does get a little funky. I'll probably screw it up at least once. But what we want to do is we want to group all of the text by some predicate into a list of, so what we want is our, I don't know, collection of a list of either text and text, where the right of the either is the text that we care about, that we focus, so in this case the words, and it will be interspersed with lefts of the white space and the new lines and the tabs and all of that stuff. So that when we're done, we can squish it all back together and we've maintained a record of kind of the ugly stuff that we didn't want to look at. So here's where the fun part is. So we need to turn our text into this. So we might need to use unfold for this. Now I'm getting into the waters I'm a little bit less certain on, but I know that there is there's like a group by where we can give it like an equality class on characters in a string, and it will basically handle that for us. So I wonder if I can just pass that like is space and see if it does the right thing. So I'm going to use this same input here, and I'm going to say group by is space. No? Space? Oh, I guess this would be from the character library, I think. So let's import data.character. And I think there should be group by is space. Yes, here it is. So this is going to check all of the characters and compare them. But I think group by actually takes 2 characters. So I'm going to say whether they are equal on is space. I don't actually know if this is going to work. I don't know what this is going to do, but easy way to find out. I think I need to import that. Yeah, import data.function, function. So this on combinator is really cool. If you do it inline, it basically runs the right part on 2 arguments and then runs the left part on both of them. So we're going to run is space on both of the arguments and then see if they are both space, if they are one is space and the other one isn't, or if they are both not space. And that will determine if they are both space or they are both not space, they go in a group. But if they're different, then we need to make a new group. I might need to not this, I guess we'll find out. What did this do? Cool. It looks like it worked perfectly. What do you know? So we can see it has segregated our string. Wow, really surprised that worked first try. Okay, so we have a character and then some space and then another, bunch of characters and then a bunch of white space and then blah, 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 blah. So now this should, we don't have it in the type system, but we have this implicit invariant that these alternate, because if they didn't alternate, then our group by did something wrong. And then we'll just report that as a bug in the text library. So I'm just going to copy what I did here, because we can use this over here. So we're going to group by, I need to import these things here, import data.function on. Any more questions from the audience? How's everybody doing? Is this actually interesting? Is there a different direction you'd like to go? I don't know. I think we're discovering some interesting cases, and this is a technique I've actually literally never seen been taught. Kind of this like mapping into eithers, and then you'll see the optics make it really nice to crunch down. And I'd like to see more people use it. It's actually extremely performant. So if you look the lens regex library, it uses the splitting technique to basically split things into matches and not matches, and then it uses byte string builders and does all that. It actually ends up being faster for doing string replaces and regex replaces, and it's more adaptable than like the built-in replaces in the PCRE regex library. It's faster, and it uses optics as a higher level API, so that's pretty cool. Cool. So we've got function and we need character is space. Great. And where was I going to use it? Right here. Cool. So, well, that's our problem. We need a where clause. Great. And let's just put undefined, like a good little Haskell programmer. Fantastic. Okay, and we need to pass this to text. Now, we don't, this is just, a list of text, but we need to map it into eithers. Now, I could use the fact that I know that it alternates, but I actually don't know which way it alternates. I don't know that it always is going to start with space and then be text. It could start with text and then be space. It all depends on, which one occurs first in the string. So in order to map this in, I'm going to probably just literally map the list. So I don't know, let's do this. So map to either, and it's going to have a little to either guy here, which takes some text and turns it into something. So if the text is space, then we do one thing, and otherwise we do something else. So maybe I'll use view patterns or something here. So I really just need to get the first character of this. Maybe we'll do unsnock or something. Let's see. Is there like an unsnock? There is. Great. Maybe text. Oh, I want uncons. We'll just get the first one. We don't really care about the rest of them. Oh, we can use all for this, I think. Is there an all? All. Determine whether all satisfy. Great. Okay. So I can say if, so we get some input text, is gonna, okay, t, and if all, t.all of the characters is space, then we, and I missed this little pipe guy here. That's it. This is the real pipe. This one's indentation. Sorry for the confusion. That probably looks weird for everybody. So if they're all space, then it's left of t, and otherwise it's going to be a right t. Great. Okay, cool. What's the problem here? Cannot match expected type bool with actual type text to bool. We need to explicitly pass it there. Great. Fun little fact about otherwise, if you haven't seen this yet, it's one of my fun Haskell facts. It's literally an alias for true in its definition. Info of otherwise is bool. It's not, and there's no syntactic sugar there or whatever. It's literally just an alias for true. It's kind of fun like this. So you could do like not otherwise, but that's stupid. Don't do that. Okay, so now all of the space goes on the left, all of the space in the box to the left, and all of the real good juicy stuff is on the right, and we have collected it into this weird little either thing. But we have this handler, right? This handler only runs on text, not on list of either text or text. So here's the fun part, cool trick. We want to focus all of these texts individually. Well, we can take our collection, okay? I'm going to use like an optics pipeline. Basically, it's like, I don't know, we don't really use pipelines that much in Haskell. We mostly compose functions, but I really like the pipelining style for this. You say, I'm going to start with this collection, and then I'm going to traverse the list. So first traverse goes around the list. I tend to use traversed because it can be more performant in certain cases, but it also does indexing for you, which sometimes you want. I don't know. It's less confusing also because when people look up traverse, they'll see that it's an optic rather than literally the traverse function. But you can also just literally use the traverse function here. That's kind of a cool thing about optics, Van-Larvel and optics at least. So once we've traversed it, now we have an either text or text. Well, we only want to focus the good stuff. So I'm going to use, say it with me, a prism. So right is a prism. We're going to use it here as a traversal. Prism. All prisms are traversals. And it knows how to take either a left or a right and only do something if it's a right and just ignore it if it's a left. So that's great. So now we dove into the list, we dove into the either, now we focused this text, and because we're using optics, they know how to automatically reverse everything that we've done. We don't have to worry about it. So we have this handler here, and it takes this function, right, text to some f of text, and we have an optic. Well, this is definitely just traverse of. Right? So we want to traverse over the focus of this optic, run some handler, some effectful handler, and then we want to pull this f back all the way to the outside. So when we run this, you can actually see in my type error here, it has run the handler on the inner text and then pulled this f out through both layers all the way to the outside. So now we have this applicative on the outside, which is what we need according to my incorrect type signature. There we go. But we still have a problem because we need to collapse all of that text back down, but we've got, you know, kind of this split thing here. So how can we do this? Well, turns out we can write an isomorphism. So if we know how to split some text and we know how to join some text, that's a reversible operation. We can go either way. So let's write collecting. It's going to be an iso, which goes from just plain old text into this cool structure here. Great. Collecting iso, and we have to and from, so this is going to be our splitter and our joiner. Okay, well, we've got our splitter here. We just need to actually have it take text as a parameter, so I'm just going to do that. I'm going to say this takes t, or I can, you know, honestly I could just do this one infix, but that's confusing, so I won't, or rather point free. So rather than collection, I'm just going to call this collect, or I don't know, whatever. No, partition maybe? Partition's a better word, but that also already exists in the prelude, so. And we want to join. So we haven't written join yet. Let's write join. So I'm going to call it joiner so we don't conflict with the monad definition. And what a joiner is going to do is it's just going to, I'll call it collapse. It's a better word. Collapse. It takes an either text and text, and it will squish them all together. How do we do that, you ask? Really nicely, actually. So we can do fold of. This comes from the lens library, and it says, well, here, let's show you the type. Let's see the type. Type fold of. Cool. Not a great. Okay. always go to the actual library because GHCI kind of clobbers them sometimes. So fold of, well, this isn't any better, but they do have other examples. So this is the one that I'm interested in. So it's interesting, the lens library always has lots of examples. You can kind of find the one that applies to your situation. And basically this is the most general one, and these are all specializations of it. So fold of can take a traversal over anything that selects as its focus a monoid, and it can collapse it down into just that monoid, which is, in our case, exactly what we want, because we have some deeply nested, we have these deeply nested, well, not super deep, 2 layers deep text. Text is a monoid, and but there's another text too. We want to focus both of them. How are we going to focus both of them, you ask? Well, if we were going to do this by hand, we would probably just do a fold map with either, you know, fold or either or something like that. But I'm just going to do it this way. So I'm going to say we're going to traverse over both, and then we are going to handle both of them. So there's, oh, what is this? Is it bitraverse? I can probably choose bitraverse, but there's also both. So both, I believe, handles, there we go. So both is a fun one. Usually you use it with tuples for basically traversing both halves of a tuple at once. But you can see in the signature, it actually takes a bitraversable as its parameter, and it turns out you can, you know, tuples are bitraversable, but so are ithers. Let's see here. Yeah, so tuples, ithers, const, you know, really big tuples, those sorts of things. Any bifunctor that is bitraversable. So that's pretty cool. So literally we just say fold over the list, traverse both, collapse it. And that will append both the junk and the good stuff together. So we can put this in here, collapse and collect, form reversible steps. And now that we have both of those, traverse of traversed right handler. Yeah, so I'm going to use my ISO of collecting. So our end result here is going to, we're going to not worry about the handler because we can write this with optics. We're going to collect everything into our either. I'm going to use my nifty thing here to traverse and then go into the right. And I can actually just do this in fix because this whole type signature reduces down to, as we see above, this traversal. So I wrote it as these three optics, and the ISO does the brunt of the work, but it's really nicely composable. Cool, let's try it out. Any questions on how that works? Please let me know. We will see how it works or does not work. So, space-preserving words, great, super short, fun to say, is a traversal. So, just like anything else, I can, let's see if I can get back my weird thing with tons of white space just for a proof of concept here. Yeah, great. So I've got this thing, it's got a bunch of weird spaces and, extra spaces in between things, stuff like that. Now let's try the original experiment. I want to reverse every word, but preserve the white space. So space-preserving words, so I guess we'll go back. So if I just use normal t.words and t.reverse and t.unwords, I need to map it. There we go. Clobbers all the white space. If instead I do space-preserving words, which, unlike the other one, this is a traversal, which means I can just use over. This says, hey, take a traversal or a lens on the left and run this function on it. This traversal happens to focus text, so I can just reverse that text. And you can see it has reversed every word in place and kept all of the white space. Everything is beautiful. Just gorgeous. Cool. We have done it. So, now for the fun part. I was hoping we'd get to this point. For those who are curious what's coming up next, well, we'll see how far we get. But I'm going to dive into indexed optics a little bit here. So, we want to, yeah. Here, let's write a new example text here. We're going to see if we can manipulate some like Markdown tables. I think I'm going to need raw string to write these sensibly. I really hate how hard this is to do in Haskell, but it's not too bad. Raw, there we go. So I'm going to import this text raw string quasi-quoter. I'm going to add a quasi-quoter here. Cool. I have to kind of close and reopen this. Okay. Yeah. No Python 3, that's fine. Okay, so I'm going to write a new piece of text, which is going to just use the raw string quasi-quoter. And it is going to be a Markdown table. So we're going to say column 1, and let's do something more fun. So what's my name? What's my city? We'll start with that. Let's just use these as column separators for now. And let's say we live in Portland. It's not true, but yeah, I'll do one in Portland. Whoops, my name is Portland. What's the name of someone who live in Portland? Eric can live in Portland. And the city is Portland. And let's say that Chris lives in Saskatoon. Alistair, is that some browser extension you're using to search Hackage? Kind of. I use these things called custom search engines in Google, but it's in Chrome. It's built into Chrome. Literally, all it is you give it a site like Google, and you say, basically, when I punch in a site and I hit tab, search Google for, and I can put whatever I want in here. And literally all it does is you give it like this string with, instead of text here, I would have like %s. And it will just, when you hit tab, it'll just run this site with whatever you typed here. So I use this for all sorts of things. It's good for like searching logs at work and like searching Google, searching other sites. I usually have one for Hackage as well, where I can basically just hit H and then hit tab and put in, the lens library, and it'll take me directly to that package. So just, I think you just click on like manage search engines or something under settings, and you can make your own custom search engines. I highly recommend doing it, especially for Google and Hackage. So works pretty well. The other nice thing about that is you can set up like Vim bindings and stuff for that. So I think I have one here. Let's see if this works. Oh, no. Try that. There we go. So I have a Vim binding that actually opens up Google for whatever's under my cursor. That's really handy. Or like, if I have, I'm curious about Traversal, or, I'm curious about what an ISO is, I can just mash my key binding. Nope, no pop-up thing. Just, maybe I'm just fast. Maybe the stream is slow. Who knows? Okay, so we got this little table here. Let's say I want to focus cells of this table in text without like parsing it. So that'll be fun. Now, how are we going to do that? Well, I think we need to generalize a little bit. So this space-preserving words now is going to need to be, I don't know, it's going to need to be more generic. It's going to need to split on predicate. All of these names are all taken, so I have to use long ones. So split on predicate is going to take, I don't know, let's just use character, Boolean predicate. It'll generate this traversal, and it takes P, and then instead of is space, we're just going to use P. It should basically work the same otherwise. So now, space-preserving words is really just, it's a split on predicate of is space. Cool. Look at that. Look at us go, just abstracting things and pulling out functions like good functional programmers. Okay, so now we've got the split on predicate. So what can I do with this that I couldn't do otherwise? Well, one thing I can do is I can write a proper lines function, or a lines traversal. So I can say split on predicate. No, I don't want split on predicate. I want good lines. This is going to be a traversal, because why not, of text to text. And good lines is going to just split on the predicate where something is equal to the new line character explicitly. Now, I'm also going to say split columns, which is going to split on the pipe character, which we use in our Markdown tables. Cool. So I'm probably going to have to do this to get this to actually be happy, unfortunately. Do this weird formatting. I just don't want lots of extra white space in there. So, okay, now for the payoff. Got our table. Great. Looks kind of stupid. Let's see if we can get all the rows of that table. Well, rows are just lines, so we can just call it good lines. I need to import. That's weird. Okay. I'm going to rename this from good lines to just lines with a little tick. I'm going going to call this columns with the tick. Actually, this one can be rows. Rows is a good one. Barry, can you purchase a physical copy? You can indeed, actually. I have not yet gotten around to exposing like a public link for that, but what you can do, it ends up being about, like, it would be the same price anyway, is you can buy the digital version, and then in the purchase package for the digital version of the book, there is a link to Lulu where you can download, or you can purchase a physical copy. So I think altogether the digital one is about $40 US, and then the book, I should check, is something like another $30 US on top of that. I don't like double charging, but just the reality of, you know, dead trees is that they cost a lot of money, and the shipping and the packing and all of that. I actually don't make much money on the physical sale, but if you buy the digital copy, you can get the physical copy through there, and the physical copies are actually really good quality. I'm pretty happy with how that turned out. They're hardcover, really nicely bound, color cover, everything like that. So that would be my recommendation. You can hit me up on Twitter afterwards if you need a hand with that. Okay, let's try out our rows and columns. So we've got our table now. Yes, table, and I want to view the columns. I sent out a Patreon link for the discount at some point. Probably, if you were a Patreon subscriber, you should already have the book bundle, and you should be able to access that on LeanPub. If you can't find it there, and you bought on Patreon, that's totally fine. Just let me know. I'll get you the link for the physical copy afterwards. Okay. Why is this not in scope? Is it? Oh, it's columns. That's why. Sorry, getting real distracted. Columns. Cool. So this splits on the pipes, but this isn't going to work properly until we split on the rows. So we're going to do row majors. So we're going to split on the rows first, and then over each of those rows, we're going to go over the columns. This is how most CSV stuff works anyways. Cool. That seems to work pretty well. And just for the sake of it, we probably want to, again, strip that white space so we can, I'm going to rename my space-preserving words to just words with the little tick there. So we can do this, and we'll do words. Cool. So here we can kind of get all of the cells of our table. That's pretty cool. But the problem is that, they're all getting squished together. So this happens a lot with traversals, where everything kind of just gets embedded in a single traversal, and you can't split it back up again. And that gets really annoying because at this point, sure, we can traverse over all the columns, but what if we only want to traverse the first column, or we only want to traverse the second column? Well, we can do that really quickly using indices. So indexed optics are one of my absolute favorite things. They give you so much power. They give you the ability to hack and slash like you wouldn't believe. Very robust, and they have a lot of default implementations for basically whatever you want. To use them, we need to add indices to things. So, oh boy, where do we want to start? This should be pretty easy, actually, because most of the optics we're building are just created from other optics. That's one of the benefits you get. So, the important one, I think, is this split on predicate. This needs to keep track as an index of which split we're mapping over. So that when we split over the new lines, we can keep track of which line we're on at a given time, and that will allow us to select a specific row. And when we split on the pipe character, we can keep track of which column we're on. So there's a type called an index traversal, and we say which type of index we want. Typically, we just use int. No, it wants flexible contexts. Of course it does. Cool. Okay, now, here's what, this is a wild thing. I just changed the type. I did not need to change my implementation at all, because, here's the trick, I'm using traversed here, and traversed is an indexed optic. So let's crack this sucker open. Da, 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 da. Traversed will automatically add an integer index over whatever you're traversing. Now, if you just put traversal in the type signature, it'll just ignore that index entirely, throw it away. And actually, it's very cool how it's wired up. You don't suffer any performance from that at all. It'll actually get written out at the type class stage. Like, it's very cool. But if you do want the index, you just have to change the type, and there it is. So now we can carry this index through to everything that uses split on predicate. So again, these just call directly through. So I should just be able to say this is an indexed, and this is indexed. Boom. Okay, now we have indices. Great. So what can we do with these? So let's say that I want only the first column. Boom, there it is. I get the names. What if I only want the second column? That did not work. Why did that not work? Oh. Columns. Really? What's going on here? As index. Oh. That's weird and... Oh, I see. So, we did something funky. That's fun. Okay, so the problem here is that it is adding the indices at the stage where it maps over every element of the list, including the white space ones, and it's indexing based on those, which we do not want. We only care about the indexing of the end result. So, are we up the creek? Of course not. There is this thing called indexing, or indexed. Which one do I want? Oh, one of these. Indexing. Transform a traversal into an index traversal. That sounds like what I want. And this just takes a normal traversal, and it will add an integer index for every focus. So if I run this on around, if this is kind of like a higher order optic, we pass it an optic and it returns a new optic based on the one that you pass it. So this should now index the result of the entire thing rather than kind of this inner part here. Cool. So let's try again. So if I, so now if I list out all of the indices, you can see, okay, we've got the first column, the second column, first column, second column, first column, second column. Great. So now I can say, okay, after I started mapping over the columns, I only want to look at index 1. And then I want to print out what is there. And we can see we get the city, Portland, and Saskatoon. Oh, and I do have some white space there, so we will again add the proper words there. Great. Cool. So that's working now. And we can actually combine them. So I can say rows index 1. So if I just want the headers, I can say, okay, let's get the first row and only the second column. And that'll get me the header. Or I can get all of the columns by not restricting the index. So this is pretty cool. So I can, specify these sorts of things. But there's something that's not great about this, is it still kind of treats them all as like a flat hierarchy, like it's just a list of focuses. What if we actually want to know which row and column it is when we get to the end? Well, I mean, if we just, so as index just basically erases the value and uses the index as the focus of the optic. I don't use it much in practice, but it's pretty handy when you're like debugging or, you know, if you want to find every index in some structure that matches a predicate. So if you're like looking through a dictionary or something and you want to see which key the index is focusing, it's handy for that. But if I do this, what? Couldn't match. Okay, doesn't like words. Okay, there we go. Okay, so you can see here, same problem. 0, 1, 0, 1, 0, 1, 0, 1. That doesn't tell me anything about the rows. The rows are getting kind of deleted. And that's just because indexing by default always will only keep the most recent indexed optic. And the plumbing behind this is a little complicated. I think it's one of those things in the lens library that were kind of an afterthought, and they did a lot of really impressive work getting indexes to actually work in here, and for the most part they work quite seamlessly. But there are a couple of cases where it gets a little tricky. But what they have done is expose these combinators that let us explicitly state how we want indices to be combined. So this is really cool. So rather than normal function composition, I can use this kind of like double arrow. There are different versions of these. There's this one. Oh, whoops. There's this one. There's this guy. And I can have both arrows at once. And basically the arrows point at the optic whose index you want to preserve. So you can only keep the indexing of the left one and ignore. So if I, for instance, wanted to keep track of the rows, I could say, well, when I compose with columns, I know columns is indexed also, but I only care about the index for the rows. Then you can see this changes. So now the first two cells are from the 0th row, second two cells from the first, etc. The right arrow one is actually the default, so that's what you get with normal function composition. But I can take both, and what this will do is it will actually just tuple those up and group them together, and I can keep both. So now I can see first one is, you know, these are basically XY coordinates with rows and columns. So 0, 0, 0, 1, first row, 0th column, first row, first, etc., right? So we can write combinators on this to basically, now we can put our indexing at the end, and we can say, well, I want row 1, column 1, and it'll just get that for us. And, you know, we can words it at the end if we want. Cool. So, getting things out of a table, that's pretty cool. Can we edit things in the table in place? Let's see. So, we probably don't actually need to words it, right? It's just kind of weird spacing, but we can deal with that later if we want. So rather than getting things, let's start to edit them. So we have our table. We're gonna edit the first column in the first row, which was Portland. But now we're gonna say they moved to London. Okay? So map over all the rows, keep their index, pair it up with the index of mapping over all the columns in each row, then filter that mapping for only the first row and the first column, and set it to London. It did not like that. I think this is another overloaded, did this get reset? Yeah, it did. Overloaded strings. There we go. So you can see it prints that out. I'm just going to actually print it. So let's import data.text.io. It's TIO. And let's tio.put Sterling. So we can print out our table, and we can see that Derek has now moved to London. It found the right thing, edited it, whatever, did the trick. We can also just delete it, right? Or we can uppercase it. So I think we're kind of getting near the end of what I wanted to get into today. So if anyone has, questions or comments or thoughts on all of this, or you have a few clarifying questions, I'm totally happy to stay on for a bit and talk about any lens or optics questions you have. Otherwise, I did write a book on all of this stuff. It's kind of, I would say it's the comprehensive resource for lenses and optics, not just in Haskell, but in basically any field right now. Not too many people have written about it. It's about 400 pages long. It covers pretty much everything you would need to know to get to the level that I'm at here, and more. So you can find that if you just search for optics by example. You can find the book there. And yeah, I'd recommend checking it out. There's a free sample you can download. It's got tons of exercises, so every chapter ends with a group of exercises with an answer key. They're pretty fun to do from what I've heard. People like them. They're quite challenging, so you can learn how to actually use the optics that you just read about, because reading about this stuff, I try to make it fun, but it can be a little dry. So exercises help solidify your understanding on that. So that's optics by example. It's on LeanPub. If you do want a physical copy, currently you just have to buy the digital, and then you get kind of a coupon code for the physical. You can go that way. But yeah, unless anyone jumps into the chat soon, I think we'll probably be done. Or if you have questions on my Haskell setup, or just questions for me as a Haskell developer, that's cool too. These indexed optics really they're very, very cool. Highly recommend people check them out. So the other thing we can do here, so optics they really do just the indexes flow through them kind of transparently. So we can do stuff like this too. So we can say, hey, get me a list of all of the rows and columns, and this @ symbol means include the index with the values. So if I do that, you can see, okay, 0, 0 is this, 0, 1 is this, 1, 0 is this. We can do this when we're mapping too. So I can, pass in the table, go over all the rows and columns, and if I want to, I can actually just set them to, and this is going to pass in the index and determine, using that index, the new value to set to. So I'm just going to show the index and then pack it. And you can see, and then we'll print it, I guess. Print it out. There you go. So I've basically replaced the contents of this table with their indices. Or if you want, you can actually do both. So you can pass in the index and the value. And there we go. Oops. Cool. I see your question. I'll get right to it. What am I doing here? So we want to show and pack the index, and then append it to the original text. That should work. So you can see, yeah, so we've got the index and the original all nicely packed up there. Question: are there easy ways to quick check hedgehog adherence of the laws? So there are libraries for this. I do not offhand know exactly what they are. I think there's some hedgehog ones. Hedgehog lens laws in Haskell. Yeah, so there's some hedgehog checkers, looks like. Actually, I don't know exactly how these work. I assume you have to provide input for the lens or the setter or the ISO, but yeah, if you look around, there are quick checkers, and there are hedgehog things for checking the laws. I mentioned a little earlier in the stream basically that the laws are not the most important thing to worry about always. They're kind of just made up, and they're handy as a basis. Like, if you're doing normal things with lenses and optics, you should definitely try to follow them. And if you're not following them, it's probably that you're operating at the wrong level of abstraction, actually, and that you need to rethink and refactor what you're trying to do with a lens. Or maybe it's not actually a lensy thing at all, and you should just use a function. That happens a lot. I have pretty long form chapters on this in the book, like when to care about laws, how to care about laws, when they matter and when they don't. And I also have some examples and exercises for like, hey, implement something that breaks, this law or that law, and they kind of show you how it's bad. So it's the same thing with like monads, right? So you kind of see like if you're breaking the monad laws, it's probably a sign that you're doing something else wrong, unless you're doing it for extreme performance or something like that. But will I upload the code to GitHub? Maybe a gist. Yeah, I can do a gist. I'll post the code in a gist on Twitter. Yeah, that's what I'll do. I'll post the code in a gist on Twitter after this. So find me on Twitter at Chris L. Penner, and it'll be up shortly after I end the stream here. I think these recordings will hopefully persist too, at least for a couple weeks. So share them with your friends. If this is something that you enjoyed and you'd like future streams on, let me know. I'm not really sure if I'll be doing a ton of them, but if people liked it and they have topics in mind, I'm happy to look at that. Maybe next time I think a fun one could be to implement optics from scratch on stream. So we can, write a lens, like write all of the lens machinery and show off how it works and why it works. Yeah, no problem. Thanks for dropping by, everybody, by the way. Appreciate it. I know there's lots of other things to do on a nice sunny Sunday. But yeah, I think it could be fun to implement some of the lenses and lens combinators and things like that, and show off kind of how they work and the Van Laarhoven approach and how it compares to the Functor version, and kind of just unpack that black box a little bit. If I work with data structures that don't fit in memory, can I still use optics? Yes, indeed you can. So it depends, of course, on your situation. If the data structure itself, can't load into memory, I mean, unless you're doing some lazy magic, optics don't fix problems with Haskell, and they don't give you infinite memory. But what they can do is they can give you pretty high level, kind of a high level interface to streaming. So, for instance, my lens CSV library, it is implemented as traversals on top of the Cassava streaming CSV parser. So basically, you give it a traversal over the rows of the CSV, and you tell it what you want it to do, edit the row or whatever, and it will do all of the streaming magic for you. So it will parse in a streaming fashion, it will run the modification in a streaming fashion, it'll write back to like a lazy byte stream or whatever in a streaming fashion. I think. I haven't done much testing on it. If it doesn't work, we can probably fix that. I just haven't had a lot of feature requests for that. But in cases like that, it can give you a really nice high-level interface for streaming. You can also, for instance, if you're dealing with a traversal, basically the signature for a traversal is just traverse. And most streaming libraries, so pipes or conduit or whatever, the way that you get values into the stream is using a traverse-like function, right? It gives you like a function from A to M of unit or something, and that's how you get values into your stream. And so you can use that with a traversal to, go deep into your object, find all of the values that you want to embed into a stream, and do that, and Haskell can handle that lazily, and typically you can stream that way. So yeah, so it can help. It's not a silver bullet, but mostly if you already have an existing way of doing it, it can give you a nicer interface. Other questions? Give it another minute, and if there aren't any more, then I'll just upload this gist and call it a day. So what did we get up to today? Thanks for coming, everybody. Appreciate it. So what we basically did, we wrote a combinator for, getting the first n characters of a text, getting the last n, or getting characters after the first n characters of a text, And we re-implemented those in terms of a shared combinator to show off what an ISO is. Then we wrote a better version of words using this shared kind of technique here that I use in my regex lens library for basically splitting things up while keeping track. So we built a better words traversal, and then did a little bit of manipulation on kind of like a table format here. Cool. Yeah, I'm not seeing any more questions, so I guess we'll call it there. Yeah, thanks everyone. Maybe see you next time. Follow me on Twitter if you're interested in this sort of thing. It's twitter.com/Chris L. Penner, Penner. I'll post a link in the chat as well, I guess. So yeah, have a great Sunday.